managed to submit your homework and send to me by email, okay? Even for the overseas students, if you submit the report, then I will give you the score, okay?
Yeah. They need some more time.
Okay, I will give you, for the overseas students, I can give you like 10 days more, okay?
Okay.
10 days, 10 days. That is by the end of, before
9th January.
9 January. Is that okay, everyone? Please respond, everyone. Is that okay?
Thank you, ma'am. They called me yesterday.
Oh, they give you a call.
They called me yesterday to take some time to take it.
How about the other students? Is it okay? For lab 1 and lab 2, you should at least send me two reports for task 1 and task 2, okay? Why there is no content? Sorry. Just wait, okay? How about the other 2 students? How about different values? I'm not sure. For task 1, there is only one simple system, that is the 9-bar system. You cannot use other systems. Otherwise, for the task 1, problem B and C, you cannot solve problem B and C, okay? Yeah, it's the same as my sample, but you have to change the values. And also you can add your own understanding in the analyze, because our work is not just about the calculation. Also you have to analyze the results, why there is a difference between the power loss or the transmission losses, and why the weightage magnitude change if we change the transmission line connection, okay? You should try to think about the reason why, and then put the answers on your report, okay? And write down your analysis for the difference, okay? And if you just submit the report, then you will get only like 70% of the score. But if you have put some your own understanding and analysis about the power loss or the weighting magnitude difference, and then I will give you score based on your analysis, okay? During last week, during last Tuesday, I have given you some examples about the unit commitment. For the unit commitment, is not very new. It starts at about in last century, in the 1980s or the 1980s. But the academia found it very interesting and important because in essence, you can find it's a mathematical problem, very complex mathematical problem, because it involves the state changing from one to each other. Okay. And then during the last lecture, I have shown you an example that contains only 3 simple generators, and then I show you a case. Case study of how to use the priority list method to find the solution for the unit commitment problem. For the priority list method, is to list all the possible states of the 3 generators. Here, because we have 3 generators, that we have we have 8 states, and then we list the minimum and maximum power generation for each state. For the state 1, we assume all the generator is turning off, so that the minimum and maximum generation is 0. Okay. For the state 8, do you have to call your classmates? Okay, give them a call.
Hello. Koi thi? Yes? Class nahi gaya. Tatare दूर tatare. Lucky.
Okay.
One student he joined in Kingston.
Sorry?
One student in our class. We are in 5 here.
Yeah.
So one student joined in Kingston meeting.
How about the other one? Is he sick or?
That's correct. He's equal to one. Equal to about it.
For state 8, that we can find that we assume that all the 3 generators is on. Once the generator is turned on, in the unit commitment problem, we assume that once it's turned on, the minimum generation for each generator, we have the minimum and maximum generation limits, and then we list all the possible combinations for the 8 states, and then we can, if we want to solve the unit commitment problem, firstly, turn off the light, okay? If we want to solve the unit commitment problem, firstly, we have to list all the states, and then we find the feasible states for the solution. For this case, apparently state 1, state 2, state 3, and state 8 is impossible. Okay, so that only state 4, state 5, state 6, and state 7 is possible And then we find the infeasible states for the solution, and then we're using the economic dispatch problem to solve this unit commitment problems. Okay, and here we can have a look at this figure. This is about the different. This is about the transition path for the unit commitment scheduling. Okay. Here we can find here, assume that we have a total 12 hours unit commitment problem. That is, we have to find the scheduling solution for the three generators. During hour 1 to hour 12. And then here, because we have three generators, that means for each hour we have 8 possible states. And then we know the starting point is here. That is, for the unit commitment, we can imagine that it's just like the figure. We can find that each different dot and each different dot represents state. Okay, so that's why we have 8 states in one line. Okay, is that clear? Is that clear so far? And then for the unit commitment problem, it is to find the optimal path for the 12 hour. Okay, if we consider this as a figure. Okay, this is a way for you to understand how the transition process of the three generator during the hour 1 to hour 12. Okay, each dot represents one state of the three generators combination. Okay. And here in hour 1, this means the three generators are working in state 5, okay? And here this means the three generators are working in state 6, okay?
State 6.
Yeah, okay. Yeah, because we have to find the possible way and the most economic way for the three generators to transition from one state to another state. Because for hour 1 to hour 12, the load demand is varying, so that the three generators cannot remain the same level, okay? Because it has to change from one state to another state. That's the difficulty of the unit commitment, because in the unit commitment problem, the generator has to turn on or turn off, okay? So that we have to consider the start-up time, the turning off time, and the start-up cost and the turn-off cost, okay? We have to consider the changing process of the different working states. Here this is an example that we have 6 unit combination, and here this is a 24-hour time period. We can find that this is a working state. In hour 1, only generator 2 and generator 4 is turned on, and this is the same for the first 5 hours. Okay, is that clear? And then during the hour 6 to hour 8, then we turn off the generator 3 and turn on the generator 6. Okay, and then for during hour 6 to hour 8, that generator 4, generator 5, and generator 6 is on. We can still look at this table. We can find that once the generator 6 is turned on, and then it continues working from hour 6 to hour 19, okay, until it can be closed down, okay. And then for the generator 3, it has once it's turned off at hour 6, and then it has to be turned off at least for 4 hours. Okay, this is the turning off constraint. So once the generator is turned off, it has to be cooled 4 hours until it can be started again. Okay, here we can have a look at here from hour 6 to hour 9, and then until hour 10 it start over again. Here we can have a look at this table. We can find that for generator 1 and generator 2, it's never been turned on. Okay, for the 24 hours, it remains turning off. Why? Because I think the main reason is that generator 1 and generator 2 is expensive, so that the system operator inclines to dispatch the cheaper ones, like the generator 3 or like the generator 4. Yeah, generator 4 is continuous running for 24 hours. Okay. So this is the solution, okay? Once we're running the unit commitment problem, we are getting 2 answers. First answer is this. Is this a table contains 0 and 1 variables. While 0 represents the generator is turning off, and value 1 represents the generator is on. And then for the unit commitment. Also, we have to get another answer. That is the generation cost, and that is the generator output power. For calculating the unit commitment, we will get the solution. We will get the solution about an average generator, how many generation for each generator during each hour. Okay. This is another example for the three generators case. Okay. Here, let's have a look at this case. It's simple. Here, for this case, we have three generators. That is unit A, unit B, and unit C. This is the lower and upper limitation, okay? And this is the minimum and minimum downtime. The minimum uptime means once the generator is turning on, it has to work at least 3 hours until it can be turning off, okay? For the minimum downtime hour, it means once the generator is turning off, it has to be cooled down for at least 3 hours until it can be started again. Okay? Is that clear? And here this is the startup cost at the initial stage. We can find that in the initial stage, the generator 1 is on, and generator 2 and generator 3 is off. That means once the generator is on, the generator A must at least running for 3 hours until it can be closed again. Okay? Is that clear? And then we are using the priority list method to solve this problem. This is the load demand variation from hour 1 to hour 3, okay? We can find the load demand here. This is a combination. This is the method we are using the priority list method because we have 3 generators. That is, we have total 8 states for the unit commitment problem. This is the possible generation output for each generator. And here we find the feasible state for each hour. Okay. For hour 1, because the load demand is 150 megawatts, so that the only possible state, feasible state, is state 4 and state 5. Okay. Is that clear? And then for hour 2, because the load demand is 350 megawatts, so that the feasible state is state 8 and state 7. Okay. And also for hour 3, the load demand is 320 megawatts, so that the possible state is state 8 and state 7. And then this is a simple illustration about how the transition starts. This green dot means the initial point, okay? Because in the initial state is in state 2. That generator 1 is on, generator 2 and generator 3 is off, turning off. That is the initial state. And then we can find out how the transition process for the 3 generators combination from hour 1 to hour 3, okay? This is the possible transition path. And then we consider the starting up and turning up and turning down constraint, and also we consider other constraint. By doing this, we can eliminate some passes. That is, this is a possible solution for the 3 hours. And then here this is the solution, okay? This is an example. And then this is what we can find the cost, okay? Because this unit commitment problem is difficult, and then I will give you some introductions about how to solve the unit commitment problem. There are many solution methods, like the priority list method, like I already told you during the lecture. That is, list all the possible states and find the feasible transitioning path, okay, for the generators. And then second way is the dynamic programming. It's a very complex computation language, but it can help you to find the optimal solution. And the third one is the Lagrange relaxation method. And number four is the mixed integer programming method. And then I will send you one sample code, okay? I will send you one sample code using the Lagrange relaxation method. If you are interested, and then you can after lecture, I think you can check the you can run in the code and then change the values and help you to understand this, okay? Okay, now I open the MATLAB screen. Can you see the screen clearly, everyone? Is that clear? Because this is the sample code which I used during my PhD study. I'm sure that you can find the other codes for the unique commitment in language, like in English or other languages, okay, or in Pakistan or Bangladesh, okay, because this is a function that using the economic dispatch using the Lagrange relaxation method. This is the main function. The main function is called UC, okay? This is the input value. The input value is the minimum and maximum generation. No need, I will give you the code. The P-min and P-max is the minimum and maximum generation for each generator, and the COEF is the cost coefficient for each generator, okay? And here, this is the input value, okay? This is the cost coefficient value for the generators, and every line refers to one generator. Here we have three generators, so that the cost coefficient matrix is a 3 times 3 matrix, okay? And then because we have the three generators, so that the P-min and the P-max is a vector contains three variables, okay? And here we are calculating a problem that is in 4 hours, so that the load demand is in 4 hours, okay? And then here we assume that we consider the renewable generation, so that the P-bin value is here, okay? I will give you some information about this code, because for the Lagrange relaxation method, it's an optimization problem. The principle of the optimization problem is to create. Let me think about it. Is to create the dual problem of the original problem, because for the original problem is a minimal problem that contains the quadratic forms, okay, and with linear constraint, okay. For the Lagrange relaxation method is to create the dual problem of the original problem and then solve the dual problem and the original problem. Once the dual problem is solved, and then we can get the solutions for the original problems. You do not have to understand the details of the Lagrange relaxation method. It's very complex. Even me, I cannot remember all the details of the Lagrange relaxation method. All you have to know is to understand the very basic meanings of it is to create the dual problem, okay? And here for this part, this is to create the dual problem of the original problem, and then we solve the original problem and the dual problem simultaneously. And then here the epsilon is the error that will exist if the error of the dual problem and the original problem is smaller than 0.05, and then we assume we get the solution for the original problem. Okay. So this is the main structure of the UC problem, and here we are using the dynamic programming method to solve this. Okay. To solve it. This part is to solve the dual problem, okay? This part is to solve the dual problem, and this part is to solve the original problem. And then we can find the result. And here, okay, let's type. Let's click the running button, and here we can see that we get the results. Okay. During 69 iteration, here we can get the solution, and then this is our from our 1 to our 4, and this is the value of lambda. And here this U1, U2, U3 is the operation status of the three generator here, and then this is the output value of P1, P2, and P3. Okay, and then this is the generation cost. For the sample code of UC, it contains three parts. Okay, the UC is the main function. Okay, because most of you haven't learned MATLAB before. During the MATLAB, sometimes if the problem is very complex, then we cannot put all the codes in one profile, so that we create a set of the editors which contains a lot of the programming, and then that is we have the main function. Here UC is the main function. If we are running UC, and then the UC will call the economic dispatch problem and the DP programming to solve the problem. Okay. For the economic dispatch problem, this is to determine in every hour the most economic power generation and the minimum cost. Okay. Here, this is to determine the most possible generation, and then change modify the Lagrange and modify the lambda as the Lagrange factor. This is the DP programming that we are using to solve. For this code, you can change the value of the cost coefficient, and also you can change the load demand, and also you can make the hour longer, like 12 hours or 10 hours. You can modify the code and to see the difference of the result. Okay. Here we can find that if we change this into 4 hours. Okay. And then we can find this is the solution for 5 hours. Okay. Because the structure is already exists. All you have to do is to modify the input values, okay? Like changing the cost coefficient of the generator or change the value of load demand, then you can get your own results. I will give you the code you see, because in this time we do not consider the wind, okay? We can just simply delete this, okay? It's still working. I will send you the code in the
I can add some more generator like wind, hydro. I can use some more generator.
Yeah. I will show you 2 examples. Okay. This is the first example, and here this is example 2. The example 2 is much more complex. Okay. It's using the dynamic programming method, but in this time, this is the input. For this programming, we have two functions. The first function is the input function. we have to input the values for the three generators. For the generation, minimum and maximum generation, and the startup and the turning of time. And then this is a dynamic programming method for solving this unit commitment problem. For this code, it's also simple. All you have to do is to click the running button, and then the MATLAB will help you to get the solution. Okay. This is a solution that for the region for our 1 to our 3. This is the load demand, and this is the code will automatically run for the results. Okay. This is some example. I know some of you are very interested in this topic, but because this is difficult, even me cannot understanding every line, the detail of every line of this code. So I just send you the code. If you get the code, and then you can modify the values when you get home. Okay. Then you can practice. Okay. Then I will send you the code during the WeChat in the WeChat group. Is that okay? Is that okay? Remember to put all the three functions, MATLAB function, in one folder and name it as UC. Okay. Once you want to practice, just running the UC programming, because this is the main function. Okay. Just simply running UC, and then you can get the answer. And also, everyone, if you are interested in the UC problems, maybe you can try to change the input values as the cost coefficients and the minimum and maximum value for each generator, or changing the load demand, because you can changing the load demand as to 12 hours or to 12 or to 24 hours, and then by simply click this button, and then MATLAB will automatically run the results for you. Okay.
This load is for 4 hours.
Yeah,
Yeah.
you can make it like 8 hours. Okay. Yeah, you can add the length like 12 hours. The MATLAB can automatically solve this for you. Okay. Since I already sent you the code, and then I will give you five minutes for you to practice yourself, and then in this class I will give you some videos. Okay. Let me check if the videos can be played. Okay. Okay. Oh, okay. We'll just wait a minute. Okay. University. I already sent you the code in the WeChat group. Maybe you can download from the WeChat. Okay. Nice.
You give us this dynamic and regulation,
Yeah.
I try to priority list.
Okay. Well, priority list is simple. It does not contain. It's not very complex.
Okay.
If you are interested in this lecture, I will also give you the PDF profiles. Okay? Do you want the profiles? Okay. Okay. I think this is useful. I'm not sure if you have learned something in this course. Did you learn something from this course? I have tried, because this is my first time to give you this course, power system practice. And in our department, not everyone is willing to teach the. No, not everyone is willing to teach the foreign students. To be honest, because we have to teach you in English. Not everyone has the ability to teach in English. So this time, for me, this is a try. This is a whole new try. Okay. If there is something that I'm not doing well, okay, please forgive me. Okay.
No problem.
Because this is my first time. I have tried my best. Okay. And the analysis, okay? Like for task 1, I want you to analyze why there is a power loss difference between the original case and the case that we add an extra line. Okay, submit again, okay? Yeah.
Because you say if we just give the answer, you will get the 70% mark.
Yeah.
But for our scholarship, we need at least 75%. So
how much for your does the scholarship cover for your living expenses? Does the scholarship cover for your living expenses? How much for a month like? Only cover for the tuition fees or the.
For my school, it only covers only tuition fee.
Tuition fees.
I have to pay every year this university 7,500.
7,500 for the living.
Yeah.
How about for the eating?
Eating is 500 or 400 every month is okay. Because Chinese food cost is not.
I can share you my experience because I done my PhD study in Australia. The Chinese government only give us about 700 Australian dollars. So I have to cook half of the car because the scholarship is not that enough. Okay, and also I have to do some tutor job for cover my living expenses.
For every student is also very important. When you study, you have to teach.
I'm sure. Yeah, I'm sure that. Please do not send the everyone. Please do not send the PDF profile, the Positive Economic. Do not submit this for the internet. Okay, you can just you can have the PDF document, but do not submit online or send it to others. Okay, because this is only for the class that we have. Because you pay for the tuition fee, so that you can have the resources, but you cannot submit to any other student. Okay. Because they do not pay for the price and only for the course is confidential, okay?
Yes.
And then for the rest of the class, I will play some videos about the smart grid, okay? I have collected some interesting videos, and I think this is interesting because for this semester we cannot have the tutoring section. We cannot tutoring the lab, so I can only give you some video. Okay. Please just wait. What's your experience here in China, in Changsha? Have you ever been to any other cities in China? So every day you stay in campus.
Yes.
Did you go to the place of interest like the Yuanwu Mountain
Yes.
or Wuyi Square?
Orange Island.
Sorry?
In Changsha we go almost everywhere, but not outside of Changsha.
Changsha is very nice, so no need to go outside.
Maybe for the next year you will have more chance to go outside to see China. How do you find the living or study experience here in Changsha? Is it hard or
It's not hard.
Almost same as our
as your country?
Is one thing I really like to pay. No need to bring cash. Just WeChat or Ali. It's easy like.
In our country, we have to bring cash.
Do you have plans to go back to your home country?
No.
I have no plan.
No.
How about you?
I'm going for when I finish, then but I come back to Moscow.
I will not go back.
I'm not sure if you have learned something during this course.
Did you mention?
Ready?
Am I not on?
Okay.
Message?
Unit computer is very complex. Wait a minute until I install the XMP player, and then we will the sound player, and then we can see the smart grid videos. Okay.
Maybe this code has something wrong.
So why? Because in my computer it can run it.
I say this name after this is not working.
I said running the man function, that is you see.
Okay.
And then why you are naming this as 3DP? Because you cannot change the names of the each editor, because for the man function, you can say that for the man function here, the man function is calling the here for this part, the man function. The man function is calling the DP function. If you change the file name as 3DP, and then the MATLAB cannot find the DP editor, and then it cannot run it here.
Running?
Yeah. So you can because here for this part, this code is calling the DP edit function. Okay. And then
for this part is calling this file of DP, yeah?
Yeah, and then here for this section, and then this is calling the economic dispatch, so that you cannot change the name. Because you haven't learned MATLAB. If you learn MATLAB, you will find this. Okay.
I learned it, but this part is deep.
Okay, everyone. Now let's have a look at the smart grid video. Okay. Let's go on with my computer again. This is about the green community. I'm not sure why there is no video. There is no sound. Even for my computer.
No speaker.
Okay, everyone. Can you see the screen? Okay. Let's see something. Okay, let's see the video. Why there is no sound? Can you see the screen? is for the Green Institute.
I have one video about smart grid.
You have the video. Okay.
Not this one.
Oh,
I have another video.
okay. Is it okay to use your computer to
Okay.
make the video?
Okay. Okay, ma'am.
Um,
Video
but-
है वो तो कैमरा खोल ले